the time-elapsed argument, and the Fermi Paradox. The Fermi Paradox is the discrepancy between the lack of conclusive evidence of advanced extraterrestrial life and the apparently likelihood of its existence. If life is so simple, then someone must have contacted us by now. Deciphering cosmic silence. The time-elapsed argument and the Fermi Paradox. Enrico Fermi's name is associated with the paradox because of a casual conversation he had with fellow physicists Edward Teller, Herbert York, and Emil Konopinski in the summer of 1950. The men discussed recent UFO sightings and the possibility of FTL travel as they walked to lunch. The conversation moved on to other topics until Fermi asked during lunch the famous question that summarized the Fermi's paradox. The Fermi Paradox is a conflict between the argument that scale and probability seem to favor intelligent life being common in the universe. The Fermi Paradox embodies the apparent contradiction between the high probability of extraterrestrial life and the absence of observed contact or communication with advanced civilizations. This paradox challenges our assumptions about the prevalence and behavior of potential cosmic neighbors. There are an estimated 200 to 400 billion stars in the Milky Way and 70 sextillion, or 7 by 10 to the power of 22 stars in the observable universe, so the first aspect of the Fermi Paradox is a function of the scale or large numbers involved. Even if intelligent life exists on a negligible fraction of planets around these stars, there may still be a large number of extant civilizations, and if the fraction were high enough, the Milky Way would be home to a significant number of extant civilizations. According to the principle of mediocrity, the Earth is a typical planet. Given intelligent life's ability to overcome scarcity and its propensity to colonize new habitats, it seems possible that at least some civilizations would be technologically advanced, seek out new resources in space, and colonize their star system and subsequent star systems. After 13.8 billion years of the universe's history, there is a conflict that must be resolved due to the absence of significant evidence of intelligent life on Earth or elsewhere in the known universe. Possible resolutions include the possibility that intelligent life is more uncommon than previously believed, that assumptions about the general development or behavior of intelligent species are flawed, or, more fundamentally, that the current scientific understanding of the nature of the universe itself is incomplete. If interstellar travel is possible, even the slow kind of alien technology that is almost within reach of Earth's technology, then it would take between 5 million and 50 million years to colonize the galaxy. This is brief on a geological scale, much less a cosmic one. Given that there are numerous stars older than the Sun and that intelligent life may have evolved earlier elsewhere, the question arises as to why the galaxy has not yet been colonized. Even if colonization is impractical or undesirable for all alien civilizations, probes could be used to explore the galaxy on a large scale. None of these have been observed. There have been numerous attempts to resolve the Fermi Paradox, such as proposing that intelligent extraterrestrial beings are exceedingly rare, that the lifespan of such civilizations is brief, or that they exist but humans cannot detect any evidence of their existence for a variety of reasons. The Fermi Paradox has long captivated the minds of scientists, philosophers, and enthusiasts alike. It poses the perplexing question: if the universe is teeming with potentially habitable planets and the likelihood of extraterrestrial civilizations is high, then why haven't we observed any definitive signs of their existence? The time-elapsed argument is a key facet of the Fermi Paradox, proposing that given the age and size of the universe, an intelligent civilization should have arisen and achieved spacefaring capabilities long before our own civilization. This argument questions why we haven't encountered or detected their presence in our exploration of the universe. The time-elapsed argument offers a possible explanation for the Fermi Paradox. Advanced civilizations may have risen and fallen long before Earth's emergence, or might be too distant to detect within our observable universe. It raises questions about the longevity of technological civilizations and the factors that could lead to their demise. Particularly, a few scientists have asserted that the absence of alien signals is due to a great filter, an evolutionary bottleneck that is impenetrable to the majority of life. If true, this great filter either existed in the past or will exist in the future. If it occurred in the past, it may have occurred when life emerged spontaneously or when single-cell organisms evolved into multicellular ones. Either way, it suggests that complex life is uncommon, and we may be the only intelligent life in the Milky Way. If, on the other hand, the great filter lies ahead of us, then the majority of advanced civilizations may eventually hit a brick wall and perish. If so, this may also be the fate of humanity. There must be chemical and metabolic limitations on the size and processing capacity of organic brains. In fact, we may already be close to those limits. But such restrictions do not apply to electronic computers and possibly not even to quantum computers. Consequently, by any definition of thinking, the capacity and intensity of organic, human-type brains will eventually be completely overwhelmed by the cognitive processes of artificial intelligence. Darwinian evolution may be nearing its conclusion, whereas the evolution of technologically intelligent beings is still in its infancy. There is little doubt that machines will eventually surpass more and more of our uniquely human abilities. Computer scientist Ray Kurzweil and a few other futurists think that AI dominance will arrive in just a few decades. Others conceive of centuries. In any case, the timescales associated with technological advancements are minuscule in comparison to the evolutionary timescales that have produced humanity. In addition, technological timescales are less than a millionth of the vast cosmic timescales that lie ahead. Therefore, the outcomes of future technological evolution may surpass humans to the same extent that we surpass comb jellies intellectually. Philosophers and computer scientists debate whether consciousness is a special property associated only with the kind of wet, organic brains possessed by humans, apes, and dogs. In other words, could electronic intelligences lack self-awareness and an inner life even if their capabilities appear superhuman? Or perhaps consciousness emerges in any network sufficiently complex? Some argue that this question is irrelevant and semantic, comparable to asking whether submarines can swim. We do not believe so. The response will determine how we respond to the far future scenario we've outlined. If machines are what philosophers refer to as zombies, their experiences would not be accorded the same value as ours, and the post-human future would appear rather bleak. If, on the other hand, they are conscious, the possibility of their future hegemony should be welcomed with open arms. Assume now that there are in fact numerous other planets where life originated, and that some or most of them followed a similar evolutionary path to Earth. Even then, however, it's highly unlikely that the key stages in that evolution would be synchronized with those on Earth. If the emergence of intelligence and technology on an exoplanet significantly lags behind what has occurred on Earth, then there would be no indication of intelligent life on that planet. In contrast, around a star older than the Sun, life could have had a head start of at least 1 billion years. If post-humans transition to fully electronic intelligences, they will no longer require liquid water or an atmosphere for the chemical reactions that led to the origin of life. They may even prefer zero gravity, particularly when constructing enormous artifacts. Therefore, it may be in deep space, not on the surface of a planet, that non-biological brains develop superhuman abilities. The vastness of the universe poses a challenge to detecting distant civilizations. Advanced civilizations might exist beyond our observational range due to the finite speed of light and cosmic expansion, making communication or interaction impractical within the confines of human timescales. The time-elapsed argument triggers explorations into possible solutions, ranging from the self-destructive nature of technological civilizations to the existence of interstellar barriers that hinder communication or contact. Proposed solutions prompt critical discussions about the nature of intelligence, technology, and the survival of species. The Drake equation, a mathematical framework used to estimate the number of technologically advanced civilizations in our galaxy, incorporates factors that influence the development and longevity of extraterrestrial civilizations. The time-elapsed argument forces us to reevaluate these factors in light of potential temporal constraints. It underscores the importance of responsible stewardship of our planet and technology, as well as the ethical considerations of our potential impact on the universe.